Hi. So in this video, we are going to be covering the interview question termed as 3-number sum. We are going to look at two methods or two ways by which we can solve this question, and definitely we are going to be coding the solution or our approaches. So the problem statement goes like this. Also, a little prerequisite to this video is the 2-number sum problem. So you can check that out in the previous video I made. So the previous video which I made was 2-number sum, and you can check that out. We discussed 3 ways, in fact, to solve that 2-number sum problem. And if you understand the 2-number sum problem, you can kind of derive insights from that problem and apply it to the 3-number sum problem. It's as simple as that. Okay. So let's get started, shall we? 3-number sum. You will be given an array here. So this is my array as of now. What are the array contents here? Let me just go through one by one. So it's -1, 3, 5, -2, 8, 6, 0, right? Now, then you will be given a target sum. So in this case, my target sum is basically 14, right? So my target sum in this case is 14. Perfect. You have to be outputting in this format. So you have to output all the triplets in the array. So what do I mean by triplets? Triplet is basically a small kind of an array consisting of 3 numbers or 3 elements. So the length of the array or a triplet is 3. As simple as that. Okay. So you have to output those triplets, the sum of which is equivalent to the target sum. So in this case, if you look at the output here, right, I'll just kind of use a different color to make sense. So 3, 5 and 6, you just kind of add them. So 5 plus 3 is 8 and 8 plus 6 is 14. And this 14 is kind of equal to the target sum, right? Not less, not greater. It's equivalent to the target sum. That's what my goal is. Again, look at this triplet, 8, 6 and 0. So 8 plus 6 is 14 and 14 plus 0 is 14. So that's 14, and that's again equal to the, or equivalent, might call it equal, equivalent, that's your wish. So it's equal to the target sum 14, right? And all of these elements or the numbers are from the array itself. So in this case, my numbers 3, 5, 6 came out from 3, 5 and 6, right? And where did I get 8, 6 and 0? Let's see. So I got 8, 6 and 0 from here. So that's 8, 6 and 0. And there is no other such combination as of now for target sum 14. If there exists, we can see that, right? I've just written 2 just to make you clarify how the output is going to look like. Okay. As simple as that. Let me just kind of dry run through the code so to see whether we can derive any 14. So -1 and then 8. No, that won't make sense. 5, 3, 6, kind of we wrote that. 8, 6, 0, we wrote that. Can we write 5, 3, 6 and 0? Because that's also 14. But hey, 5, 3, 6 and 0, that will be 4 elements. I want a triplet, which is 3. So that's not possible, right? Again, I just gave a little insight to what is possible and what is not. So I hope the intuition behind the problem is clear, and you have to be outputting this triplet kind of an array here, right? That's it. As simple as that. So let's see the 2 ways we can solve this problem. The first way is kind of like the naive approach or the brute force approach, where we are going to do or make use of 3 for loops, or you can use while loops, whatever your wish is, right? So let's get started with that. It's always optimal to start with it's always okay to start with the brute force approach, because that's going to build up the optimal solution in the longer term, right? In the longer run. That's what I mean to say. So, I mean, we have the array here, right? So I have the array here. So it's -1, 3, 5, -2, 8, 6 and 0. So what I'll be doing is I'll kind of run one loop. So that's n. So n is nothing but the length of the array, right? So that's n is nothing but the length of the array. So the first loop is going to run for n times. The second loop is also going to run for n times. From the first loop, I'll get the number 1. From the second loop, I'll get the number 2, right? So that's num2. For the third loop, which is also going to be running for approximately n times, right? We are going to be getting the number 3, right? We are going to get the number 3. Now, we are going to add all of these 3 numbers. How? I'll just kind of create something like current sum, right? Current underscore sum. That should be num1 plus num2 plus num3, right? As simple as that. Now, when I get the current sum, right? When I get the current sum, I'll just check that if my current sum is equivalent to the target sum, then in that case, I'll include num1, num2, num3 in a triplet. So n1, n2, that's num1, num2, num1, num2, and then num3 in my array. And then I'll check for the other numbers. So what is the time complexity here? What is the time complexity going to look like? Again, I'll be coding this out, so you don't need to worry about the code. You just need to understand here that's That's why I'm going to explain it here on the open board or the whiteboard. So let's see the time complexity or analyze the time complexity. The time complexity here, in the worst case, will be actually big O of n cube, right? Not n square or n log n, something kind of like that, right? So it will be big O of n cube. Why? Because here we have one for loop. That's the first one. This is the second one, and this is the third one. So that's nothing but big O of n cube. That's nothing but time complexity, TC. What is the space complexity? Well, we have something kind of on the optimal side here. Space complexity is big O of 1. But hey, space complexity won't be really big O of 1 because computing all of those numbers sum won't really take space. But storing the output in this format, in the format of an array, might contain at most n elements or close to n elements, right? It won't be really exceeding n, right? So it won't be n plus 1 or n plus 2. It might be close to n minus 3, n minus 10, kind of like that. So space complexity also is going to be big O of n and not big O of 1. That's what I wanted to clarify here. Right? So space complexity is also going to be big O of n. Why? I'm going to be storing something, right? What I'm going to store? I'm going to store this output array here, right? I'm going to store the output array here. And that's why we have a space complexity of big O of n and time complexity of big O of n cube. Can we do better? Let's see. So this was our first approach. Let's see if we can do better. What I'm going to do is kind of quickly check with the array here. So we have -1, 3, 5. I'll just write it here. So we have -1, 3, and 5. And then we have kind of like -2, 8, 6, and 0, right? -2, 8, 6, and 0. -2, 8, 6, and 0. I'm kind of bad at memorizing numbers, so I just kind of dragged it and saw it multiple times. So -1, 3, 5, -2, 8, 6, and 0. Perfect. So this was our array. And let's not forget our important thing, which is the target sum. In this case, we have a target sum of 14. Doesn't matter whatever the target sum is. We have to just solve the problem here, right? That's what our main goal is. So let's see. This is our target sum or the required sum. I'm going to be explaining one approach, which is kind of using some intuition or background or some elementary concept, which I have explained in the 2-number sum problem, right? And again, I have explained that. So it's a prerequisite to watch it. If you haven't already, you can watch that or you can skip it as of now. Nothing, no worries. We are going to be using the concept of 2 pointers, right? And again, how do I make the efficient use of 2 pointers? By sorting the array. So my first approach as of now will be to sort the given array. So upon sorting the array, right, on sorting the array, so I'll just kind of write sort function here, right? So after sorting the array, my array will look like something like this. So -2, -1, right? So that's -2, -1, and then we can have maybe 0, right? Then we can have 3, 5, 6, and 8, right? So that's 3, 5, 6, and 8. I was just marking them so that I make sure that I'm covering each and every element. That's it. So this array is as of now sorted. Okay. Now I'll run 2 loops here, right? I'll run 2 loops here. The first one is going to be a for loop and the second one is going to be a while loop. We'll see why. Okay. So the first one is going to be a for loop, right? So how do I do that? Well, you can kind of see here. I'll just kind of write the indices here. So that's 0, 1, 2, 3, 4, 5, 6. Many like to call this index. Many like to call these indices, whatever the case may be. It's the same thing, right? Now, I'll be running the for loop. So my first number will be in my for loop when I'm at 0th index. So my num1 is actually -2. Okay. My num1 is actually -2. Perfect. Okay. Let me just write it properly. My num1 is -2. Okay. My num1 is -2. Now I'll have a left pointer here. I'll have a left pointer. Left pointer's value will be I plus 1. So this is basically I equal to 0, right? So this is at a point when I is equal to 0. I is my first for loops index kind of a thing. So my left pointer will be at I plus 1. Okay. My right pointer will be at n minus 1. N is nothing but the length of the array, right? N is nothing but the length of the array. As simple as that. Okay. So up here, I can kind of write in maybe green. So my left is on 1 and my right is on 6, right? My left is on 1 and my right is on 6. Perfect. No worries. Now I'll compute the sum of 3 numbers. What are those 3 numbers? The 3 numbers are num1, so that's -2, plus the element at the left index in the array, so that's -1, so plus of -1, plus the element at the right index in the array, that's 8. Now I'll check the sum here, so that's 8 minus 3, which is 5. I'll check that again. Hey, is 5 equal to the target sum, which was 14? Target sum was 14, right? Is 5 equal to 14? No. So whenever my current sum, so that's CS, right? So CS, my current sum is less than the target sum, I'll move my left pointer to one step forward. Why am I doing an increment to the left pointer and not an decrement to the right pointer? Because hey, that's the array is sorted. I know for a fact if I have a sum less than the target sum, I want to reach somewhere close to the target sum or equivalent to the target sum, I'll just simply move my left pointer to the forward, right? Because hey, the array is sorted, so my next number will be bigger and I'll be closer to my target sum. And again, this is something I've explained in the two-sum array. That's why I'm mentioning again and again that it's a prerequisite to this video. Okay. So my current sum, which is 5, is less than 14. So I'll move my left pointer to one step forward. So it's going to be looking like this. A left sum or the left pointer as of now. So my left pointer is at the second index. Again, I'll compute the sum. So my new sum, as of now, my new sum, I'll just erase this entire current sum variable thing which I computed. So I'll write here my current sum or the new sum as of now. It's num1, so that's -2 plus left pointer, right? So the left pointer, what is the number? That's 0 plus 8, which is 6. Again, is 6 equal to 14? No, 6 is less than 14. So I'll move my left pointer to one step forward. So my left is going to be at 3. Again, I'll just compute the sum. So it's going to be basically, I'll just kind of dry run here until unless we kind of reach that point where we have the actual answer. So -2 plus 3 plus 8. What's the answer? So 8 plus 3 is 11. 11 minus 2 is 9. 9 is less than 14. I move my left pointer to 4. My left pointer is at 4. Okay. So that's 5 plus 8 is 13. 13 minus 2 is 11. 11 less than 14. Again, move my left pointer to one step forward. So my left pointer is at 5. 8 plus 6 is 14. 14 minus 2 is 12. 12 less than 14? Yes. So I'll move my left pointer to here. So left pointer is at 6 and right pointer is also at 6. And my second loop, which I mentioned, while loop, is going to be running like this. So while my left pointer is less than the right pointer. So as of now, my left pointer is 6 and my right pointer is 6. So is 6 less than 6? No. 6 is equal to 6, but not less than 6. So here I'll just break, right? I'll break here, right? Now I'm going to be moving to the next thing, which is -1. Okay. So I'll just kind of erase entire thing here. I'll write it over again. That's not an issue. So that's going to be 0, 1, 2, 3, 4, 5, 6. Now, as far as I remember that we had no answer with the -1 thing, right? We had no answer with the, by taking the -1 number. So what I can do here is I'll just simply assume that, okay, we are on the second index. We are beginning at the second index. So we are at I equal to second index. So what is my num1 as of now? Num1 is nothing but actually 0, right? So num1 is actually 0, right? As simple as that. Where is going to be my left pointer? It's going to be at I plus 1, which is at 3. Where is my right pointer? Right pointer is at n minus 1, which is at 6. So again, I'll just kind of quickly draw the left pointer here. So left pointer is at 3, right pointer is at 6. Again, I'll compute the sum here. So my current sum is going to be the num1, which is 0, plus left pointer, so that's 3, plus 8, which is 8 itself. So that's 11. Again, is 11 less than my target sum? Yes. So I'll move my left pointer here. So I'll move my left pointer to one step forward. So what I can do is I'll move my left pointer from 3 to 4. Again, I'll compute the sum here. As simple as that. So 0 plus 5 plus 8. 8 plus 5 is 13. Is 13 less than 14? Yes. So again, I'll move my left pointer to one step forward, right? Again, I'll move my left pointer to one step forward. So from 4, my left pointer will be at 5. Here comes the interesting part. Check out that 0, right? So the 0th or the num1 plus 5th index, so left pointer plus the right index, which is 6 point, right index is at 6th, right? And left index is at 5th. So it's 6 plus 8, which is 14, plus 0 is 14. Now my 14 is equal to 14. And this is the point where I'll store these few numbers. So 0, 6 and 8. Hey, again, the order does not matter here. Order is not something you have to worry about, right? So this is going to be my output. So my output array as of now is going to look like this, right? It's going to look like this. Now I'll again proceed. So as of now, what I can do is, once I match the condition here, right? Once I match the condition here, I'm going to be updating my left pointer to one step forward and my right pointer to one step backwards, right? So my left pointer is going to be one step forward and my right pointer is going to be one step backwards. Because for one number, right? So because for one number, we can have multiple answers, right? We can have kind of like multiple answers. Let me just kind of think of a case where for one number, we can have multiple answers. So consider a number like 3 is here, right? As of now, 3 is here and few numbers are there in between. And then we can have a number like 5, right? Again, the array is sorted here. You don't need to worry about that. We have 5 here and then kind of like we have 10 here. Okay. So what is the sum here? So that's 5 plus 3 is 8. 10 plus 8 is 18. So just assume my target sum was, so my target sum was as of now TS, target sum is 18. So this is my number 1, right? This is my number 1. This was my left pointer initially. This is my right pointer. And there are few numbers in between. So as of now, I got some answer here, right? So 3 plus 5 plus 10 and you are happy. Hey, my 3 plus 5 is 8, 8 plus 10 is 18 and we got the match. So should we break out there? No, we are going to be, this is a special case here, which in the 2 number sum we have not written there. So when there is a match, I'll update my left pointer to one place forward and my right pointer to one place backwards, because there might be some answer existing up here as well. How? Let's see. What if after 5 there was a number 6 and what if before 10 there was a number 9, right? So what will be the sum now? So at this point my left pointer is at 6. Let me just draw it with the other lines. So as of now my left pointer is at 6 and right pointer is at 9 and there are few numbers in between. We don't need to worry about that. What is this sum now? It's 3 plus 6 plus 9. What is it? So 3 plus 6 is 9 and 9 plus 9 is 18. Again, we got the target sum equal to 18. So for one particular number, we can have multiple answers or multiple doubles. So for 3, I had 5 and 10. So that's 3, 5 and 10 in my output. And for 3, again, we had 6 and 9. 3, 6 and 9. So that's something you have to consider or check for or validate for in this question. That's the beauty of it, right? This is the beauty of the 2-pointer approach with the sorted array in mind. And I hope the explanation is kind of crystal clear. So let's get started with the coding part. What I'll be doing is I'll be using the Visual Studio Code. Again, that's something which I've been using since the past 3 or 4 videos. So what I'll do is I'll kind of make a function like define solve1, right? Because I'm going to be solving by the first approach, which is a big O of n cube approach. So solve1, it's going to take the array and the target sum, right, as arguments and not parameters. It's not called as parameters. When we are kind of passing the values, then it's called parameters. When we are writing the function definition, it's called arguments. So something here and there about the elementary level. So define solve1 array target sum. What we are going to do, this is the naive approach, right? So this is the first approach or the kind of like the first approach slash naive slash brute force, right? And what was the time complexity? So it was, I think so, big O of n cube. So I'll just kind of represent cube as this. There might be some shortcut. As of now, I don't remember it, but hey, that's it. And what is my space complexity? So SC is big O of n, right? What I'll be doing is I have to solve this in a big O of n cube approach, right? Let's see. I don't even need to sort the array here because that's what we were doing in the second approach. So what I can do here is I'll just simply run a loop for I in range n, right? And actually my n is something which I have not declared yet. So I'll just write n is equal to len array, right? As simple as that. I'll just kind of make sure that we are on the recording thing. Perfect. So what I'll do is continue with the code here. So for I in range n, so my num1 is nothing but array of I, right? And then I can kind of use a second while loop for I in range. Should I be doing I till n for j in range? I till n. Should I be doing I till n? No, I'll be doing I plus 1 till n, right? I won't be considering a number twice. That's something you have to keep in your mind. My number 2 will be array of what? Array of what? Array of I or array of j? It should be array of j, not array of I. Array of I is something num1 is taking care of, num2 is taking care of array of j. I'll run a second for loop. So for k in range, what should it be? Should it be I plus 2 or j plus 1 or I plus 1? So that's something you have to take care of. Pause the video and think about it. So it's going to be j plus 1 and not even j. Some might consider it as j plus n, right? But no, that's not the case. It should be j plus 1 till n, right? So for example, the array is 1, 2, 3, 4, 5, 6, right? You have to consider one as, for example, the ith one, second one as the, so what I'm trying to say here is, I'll open the open board. So consider this array. I'll just consider one simple array, right? So this 10, 11, 12, 13, 14, and then 15, okay? So my I is at this position, j is at this position. So for considering k, I won't consider k from here, right? That's illegal, or that won't really make sense. I'll consider k from here. So I is at suppose 0, j is going to be at 1, which is I plus 1. K is going to be at 2, which is actually j plus 1. That's it, right? So that was a little here and there. I just wanted to make you clear about what we are doing there. So for k in range j plus 1 till n, my num3 is actually array of what? I or j or k? It's going to be k, okay? And now my current sum, so that should be current sum. Whoops, my bad. I made a spelling mistake there. So it should be num1 plus num2 plus kind of like num3, if I'm not mistaken here, okay? So I'll check here that if my current sum is equal to my target sum, in that case, well, I've not initialized some array. So my final underscore answer, or I can just kind of write valid triplets, right? It's an empty array as of now. So what it should really be? So it should be valid triplets dot append. I'll be appending my num1, num2, num3. So num1, comma, num2, comma, num3. So it's going to be appended in that format, in a list format, right? As simple as that. And after all of these is done, I mean, after all of the execution has been done for the for loops, what I'll be doing is simply return the valid triplets. And this is my first approach, as simple as that. Yes, the approach is taking a big O of n cube, but if you want to gain the impression of the interviewer, just go with the naive approach, brute force approach. Then you can kind of improve it. That will really make a lot of impression that you kind of knew the brute force approach, and then suddenly you kind of came up with an optimal approach. So he'll be like, you learn faster, right? So we'll just kind of see the second approach. So I'll be writing solve2 here, and then we'll have the array and the target sum here. Okay, as simple as that. I'll sort the array here. So array dot sort. Here's the interesting part. What is the time complexity here? Time complexity for sorting in an efficient way will be n into log n. What is the sort function here? What is the sort function here? What is the implementation of the sort function used here? So that's dot sort is kind of like tim sort, and you can again check that out over Google, right? You can kind of Google that. That's not an issue. So you should be knowing these small things. So in Java and Python, it's the dot sort is kind of like the tim sort function. Okay. So array dot sort has been done. It's going to be taking n log n time complexity. That's not an issue for us. Okay. So I'll running a one while loop here. So for I in range n, and again, I have not declared n here. So I'll just simply write n is equal to my len array, right? I'll just make sure we are on the recording page. Perfect. So what I'll be doing here is, for I in range n, I'll have my number 1 here. So that's num1 is array of I, right? I hope that makes sense. And then I'll be having my left pointer here, which is at I plus 1. And my right pointer is at n minus 1, right? As simple as that. So I'll be running a loop, not really a for loop. As I mentioned, it should be a while loop. Again, this is something which I have discussed in the to sum number, right? So to sum number. Again, I'll kind of show this here. So I'm on the two number sum or two sum number. You can kind of think of it like that. So here's the thing here. So in this third approach, so it should be third. So in the third approach, right, I've discussed about this same concept, left and right. And it was a big O of n because, hey, that was two number sum. I have to retrieve two numbers which add up to the target sum, right? So that's about it. So let's continue with the 3 number sum. So this is something I've discussed in the 2 sum number or 2 number sum approach. Okay. So while left is less than right, my current sum, my current underscore sum is going to be num1 plus array of left plus array of right. Oops, my bad. That's a little spelling mistake here and there. And I'll check now that if my current sum is actually equal to the target sum, in that case, I'll increment my left pointer to 1 step forward and I'll decrement my right pointer to 1 step backwards, or by decremented by 1 value. You can kind of say it like that. I like to say it by saying that hey, I'll be moving my left pointer to 1 step forward. Or you can say in other terms, I like to increment my left pointer by 1. It's as simple as that. Go both ways, it's easier. Else I'll check that if my current sum, right, is less than the target sum. In that case, I'll just simply move my left pointer or by 1, right? Else my other condition is nothing but current sum is greater than target sum. So I'll kind of move my right pointer by -1. So I'll decrement my right pointer by 1. Okay. And actually in this case, right, so when the current sum is equal to my target sum, what I'll be doing is I'll append the value here. So valid triplets dot append, my value should be num1 comma array of kind of like left, right, and then array of this should be right. Perfect. And I think so I have not declared the valid triplets again, so this should be valid underscore triplets is an empty array as of now, as simple as that. And now that we are done with this, right, we are just going to simply return valid triplets, right? Let's just kind of dry run one small example. So I'll just use the second approach to solve this. So I'll just kind of print solve2, and then I'll just pass in my array here and the target sum. So let's suppose the target sum is 14. I'll just pass in the input we discussed on the whiteboard part. So that's nothing but -1, 3, 5. So that's -1, 3 and 5. I'll just take a little time here. So -1, 3 and 5. And then I think we had 8, right? We had -2, 8, 6 and 0. -2, 8, 6 and 0. So that should be -2, 8, 6 and 0, right? Let's see if our code works here. We might be wrong, right? I mean, I might be wrong as of now because you are not the one who is writing the code. So I'll kind of save it here and try to run the code. So basically I'll be writing here Python 3 and my file name is basically 3 numbersum.py. Let's enter. So we got 0, 6, 8 and 3, 5, 6. The sum of which is 14. Not the entire one, but the individual sum. So 0, 6, 8, I'll just kind of highlight here. So you can see here that 0, 6, 8 sum is 14. 3, 5, 6 is 14. Right? As simple as that. Here's the trickier part. What if I put something which is not even existing there? So what if I put a 20 value? Right? What if I put 20? Let's see what will be my output. My output is going to be nothing. It's an empty bracket because there exists no triplets in the array, the sum of which is 20. As simple as that. And that's pretty much for our approach. Also, the time complexity for the second part or the second approach is going to be big O of n square. Let's analyze why. Okay, let's analyze why. It will take a couple of minutes or so, and then we'll be done with the video actually. So sorting part, right? The sorting part is taking big O of n log n, right? I'll just simply write this as it's going to be taking n log n. Okay, so that's sorting part is taking n log n. What is the main part where the computing part is taking? So the main part or the main code is actually taking n square, right? We are running 2 loops, right? The first one is a for loop and the second one is also a loop, but in the format of a while loop, right? So while left less than right. It's also going to be at max in the worst case, it's going to run for big O of n times. So that's n square. Kind of add them up. So that's n square plus n log n, right? So I'll kind of neglect this part and my answer will be big O of n square because, hey, we are taking the big O notation, which is the worst case time complexity thing, right? And we all know that the worst case kind of, we focus on the bigger part, right? So if I write n square plus n, that's nothing but big O of n square, right? If I write n plus log n, so that's big O of n. That's something which we all know, right? And again, the space complexity for any of the approaches, it's big O of n. Space complexity for any approach is big O of n, because we are storing something, right? In the best case, when there exists no target sum, the space complexity is big O of 1, right? Because we are never going to be utilizing space. As simple as that. So I hope the video was helpful and informative on the other hand. And maybe we can, if you like the video, first of all, if you like the video, then kind of subscribe or like, and then you can also follow this Instagram page I have created, termed as Interview Preparation 100, wherein I post video updates of the videos I'm kind of making, right? So I post a video update there, and then I kind of post it on YouTube there. So you can kind of get regular updates, right? So you can kind of check that in the description. I'll be attaching the links. Also, if you have any queries, any slide queries, you can reach me on LinkedIn. Again, that's something in the description, or you can check the about info page from my channel, right? So everything will be actually available in the description. So I hope the video was helpful and informative, and we can meet in the next video with any other interview question topic. Thank you.